6.7 is graphing and solving quadratic inequalities. So this is not that hard. It's just going to involve like less than or equal to, so we're going to have interval notation in the end, but it's a pretty quick section. So it says a quadratic inequality in two variables is an inequality that can be written in the form y is greater than, less than or equal to, greater than or equal to, ax squared plus bx plus c, where a, b, and c are real numbers, a is not 0. Okay, so what it says, if I have like y is greater than x squared minus 6x plus 5, I just graph that parabola. Do you think the parabola will be dotted or solid? Dotted. And then what will we plug in to see if it's going to be shaded above or below?
0.
0, 0, right? Does that make sense? So it's just like with lines. It's just now you're going to have like a little curve, right? So if I'm graphing this, one way to graph a parabola, remember, is to find the axis of symmetry. So if I do negative b divided by 2a, I get negative 6, so plus 6 all over 2 times 1. So my axis of symmetry is going to be at 3. Maybe I shouldn't draw that in because, well, that's fine. We'll erase it in a second. All right, so now I want to find my vertex. So I'm going to do y equals 3 squared minus 6 times 3 plus 5. So I get 9 minus 18 plus 5. So I get negative 4. So that means my parabola is way down here at 3, negative 4. Starts there. If I wanted to find the zeros, the x-intercepts, do you guys remember how to find x-intercepts? Plug in 0 for y, and then how do I solve something like that? Right, we're going to factor it. So we're going to have x minus 5 and x minus 1. So we get x equals 5 and x equals 1. So at 5, oops, 2 over. So 5 and 1, we're going to have our zeros. Okay, now I'm going to erase that dotted line for now. Don't you guys wish you had a magic eraser like I do? Like you just erase quickly? It's kind of fun. I like when I do Control-Z and all my writing goes away too. All right. I sometimes forget when I'm like using the board. I'm like, oh, I don't like using the board as much. All right, so we're going to draw it in with a dotted line. And then we pick 0, 0, which if you can't tell where 0, 0 is, if you're like, oh, I can't tell if that's like on the line or not on the line. In this case, it's not. It's below the line. Do you guys see it? But if you can't tell, you can always pick another point. So if I plug in 0, 0, I get 0 is greater than 5, which is false. So I don't shade 0, 0, so I don't shade that way. Instead, I shade away from it. So instead of shading below the parabola, I shade above the parabola. So just inside. So like inside or outside. And that's it. Easy enough? Not really. So it says, using the graph above, what do you think it means if I asked where is x squared minus 6x plus 5 greater than 0? So what I'm saying is, where is the parabola higher than the x-axis? That's what that means. So where would it be higher than the x-axis? Just the parabola part. So if I sketch that out, we had it crossing at 1 and 5. And we're saying, where is it above the x-axis? It's only in those two places. Goodness. So I don't worry about the part that's below the x-axis. I'm only worried about these two parts here. And so what we would end up doing is we would factor. We'd say, oh, we have x minus 5 and x minus 1. And we'd get what we call critical values. So we'd say, okay, well, my x-intercepts are at 5 and 1. And then we put them on a number line and we check each location. So which ones were greater than 0? When I was less than 1 and I was bigger than 5, right? Here and here. The one that didn't work was in there. You guys see it's like the ends? And so our answer would be negative infinity to 1, parenthesis, union, 5 to infinity. Okay. So there has to be an easier way to do this without graphing. So we're going to learn how to do that without graphing. And that's what 6.7 is about. All right, oops, I don't know, I just did extend page. All right, so next up. So it says in order to solve quadratic inequalities, so if you just have x, so if it's like x squared is greater than something, greater than 0, we need to find what we call critical numbers. So these are the values that would make the right side equal to the left side. So we find our critical values, we plot the critical values on a number line, we test points that are in each interval to see if it's true or false, and then we graph our solution set. And then we write our answer in interval notation. Okay, so if we do examples, this will totally make sense. It's not a hard one. All right, so I'm going to subtract or add my 3 over. So I get plus 21 is less than or equal to 0. And I factor. So it factors into x minus 3 and x minus 7. So if I'm finding where that's equal to 0, those are my critical values. So I have x equals 3 and x equals 7 are my critical values or critical numbers, whatever you want to call them. We'll say numbers. Okay, so what we do with these numbers is we put them on a number line. And then we test in each location. So if I try a 2, so sometimes I do like a little chart. So I say x minus 3, x minus 7, and I want for it to be less than or equal to 0. So if I try 2, 4, and 8, do you guys see why I'm putting these numbers? On the left side, in the middle, on the right side. Pick a number in each spot. Doesn't matter what you pick. You could pick like 2.7 if you want. It doesn't matter. And we try it in the factored form. So if I plug in 2 into the factored form, all I'm worried about is the sign. When I plug in 2 here, do I get a positive or negative number? Negative, right? When I plug in 2 here, do I get a positive or negative number? Negative. So I have a negative times a negative. So what is a negative times a negative? A positive. All right, now if I try 4, if I plug in 4 right here, what do I get? Positive or negative? Positive. If I plug in 4 right here, what do I get? Nope, 4 minus 7, negative. So a positive times a negative is a negative. If I try 8, positive. If I try 8, positive. Positive times positive is a positive. So I get a positive, a negative, and a positive. And it doesn't matter what numbers I pick, I will always, if I pick a number in that interval, I'll get a positive, and then a negative, and then a positive. And we want where it's less than or equal to 0. So what do we want? Yeah, we want the negative ones, right? So you said 4. We want this interval here. We want where it's negative. So we shade that final answer. Endpoints, filled in, open. Yeah, we close them in, fill them in. Why do we fill them in? Because it's less than or equal to, and those are the ones that made it equal to 0. Okay, so our answer ends up being bracket 3 to 7. Okay, and that's our answer. Now we do this type of thing all the time in AP Calculus. So if you guys go on to take calculus, we do like critical numbers constantly. Okay, does this make sense? Now if you think about the graph, I always think that's easier. I know that it's crossing at 3 and 7. And I know that it's an upwards parabola. So where is it going to be negative? Right here. So I just kind of say, oh, it's going to be positive, negative, positive. My negatives are going to be right there. So if you can do that and you understand that, do it that way. But if not, then just do this table, which will be useful to learn anyway, because we're going to do it in calculus. All right, so same thing here. So x squared plus 8x, subtract the 9 over, greater than 0. We factor. So I'm going to have x minus 1 and x plus 9. So my critical values are going to be 1 and negative 9. I put those numbers on a number line. And I test in each interval, left, middle, and right. So what should I get on my table if you guys kind of think about it? If I try like negative 10, when I plug negative 10 in, I get a negative 11 times a negative 1. So negative times negative is a positive. If I try 0, that's between negative 9 and 1, right? If I try 0, I get a negative and a positive. Oops. Yep.
Is there supposed to be a or equal to sign?
Not in this one because it's it started out with a greater than. Oh, are you saying here? Yeah, thank you. All right, and then if I try 2, I get positive and positive. They multiply to be a positive. So what do we want in the end? 2 in a row. You did yesterday too, didn't you, Kenzie? All right, so we want a positive. So because it said greater than, we want positives. So we want this interval and this interval. So plus minus plus, we want on the left and on the right. And then our circles are open. Does this make sense? Do you guys get it? Pretty easy, right? So it's going to be negative infinity to negative 9, parentheses, union 1 to infinity. That's our answer. Yeah, Cole?
So could you just tell that by looking at the sign that you have no problem?
Yeah, if you say greater than and you're like, oh, I have an upwards parabola, it's going to be on the ends. Yep, you could do that as well. That's why I was saying it's a lot easier if you realize that. All right, so same idea on this one. We can pull out a GCF of negative 3. We would have x squared, let's see, plus 2x minus 3. So we'd have that. So when we factor, we'd have negative 3, and then x minus 1 and x plus 3. So we do our number line. So I'd have negative 3, and I'd have 1. Those are my critical values. I guess I should have written those. And then I can test in each location. But this one's a little bit tricky because now we have a negative 3 as well. That's going to mess up our signs, right? And we want that it's greater than or equal to 0. So if we try like negative 4, 0, 2, if I try all those points, don't forget that you have a negative before you even begin on these. So you might put the negative out front. And then you're plugging into these two. So if I plug in a negative 4 minus 1 is a negative. Negative 4 plus 3 is a negative. Negative times negative times negative is a negative, right? The same idea here. So if I plug in 0, I get a negative. If I plug in 0, I get a positive. So I get a positive. And if I plug in 2, I get positive, positive. So I get a negative. And we want where it's greater than or equal to 0, so we want on the inside. Now there are other ways that you could do this. So our answer should be bracket, negative 3 to 1, bracket. So think about the different ways you could have done this. If that negative 3 out front bothered you, you could divide it over to the other side. But be careful, when you divide that negative 3 over, do you guys remember my red flag rule? Yeah, you'd have to flip that sign to less than or equal to. Okay, so you can do that, or you can think, oh wait, this is a downwards parabola, right, because I had a negative 3 out front. So it's a downwards parabola, so where is this downwards parabola? If you think about the sketch, it's crossing at negative 3 and at 1, and it's downward, so where is it greater than or equal to 0? In the middle, right? So you can do it that way as well. Make sense? All right, I think that's all I really want to do. We can do other examples, but do you guys understand how to do this? All right, we'll stop there. Let's give us a little bit of time to work.